So, great. So, yes, so welcome to join us for this session at ISARC conference this year. For this session, this is a very informative and interesting session because it's a combination of short papers and industry papers, which including computer visions, mobile gantry systems, robotic inspection, digitalization of prefabrication processes, and also digital fabrication for rebar. So you can see that the content is very broad and very informative, and also I hope that you guys will enjoy the session. And please provide your question in the chat box or raise your hand so that our colleagues at the on site can help you to moderate the session and in your question. Okay, so welcome everyone. So may I ask first the first speaker, Eyob, to first present his paper, which is about 3D scanning computer vision of comparing terrestrial laser scanning and photogrammetry technologies in his research. Welcome, Eyob.
Thank you, Professor. I will share my slides and I'll start my presentation. Can you see my slides clear?
Yes, yes. I hope on site also I think can see it as well. Yeah.
Okay, my name is Eyob Mengiste. I am from New York University in Abu Dhabi's Smart Construction Research Group. I'm going to present our research work by the title of Comparison of Terrestrial Laser Scanners and Photogrammetric 3D Data Acquisition Techniques for Considerations of the Developing Countries. This is a short paper, and we meant to present it as a poster. However, since there are no poster sessions in this conference, we are presenting it in person here, in presentations in here. I will start my presentations. First, about the background. So, data acquisition techniques usually improve for the construction's project control and productivity. And to enhance productivity and to have a proper construction project control, we need to have a high infrastructural access, or we need to have costly equipments. Or if we have all these two, then we need to have a computational power to process the data that is already collected using these items. Even if we have satisfied all these requirements, then we need to have skilled or trained manpower. And this could be somehow a question for some sort of construction projects if there are a scarcity in funds, or if the locations of the constructions are somehow difficult to have access to these resources. Come up to our point in here, we compared our methodologies that we have initially mentioned using these 4 criteria. Among these 4 criteria, 2 of them are quantitative and 2 of them are qualitative. The first 2, quality and economy, are quantitative comparison criteria, and feasibility and value added to the construction site are the qualitative comparison criteria. The techniques that we have compared using these criteria are mainly photogrammetric methods and terrestrial laser scanners, but these 2 methods are conducted on site using 2 different modes. The first one is static mode, and the second one is a free moving mode. The difference between these 2 is for the photogrammetric methods, some selected locations within the construction site are spotted, and then on those locations, a camera mounted on a tripod is placed, and the pictures are taken using multiple degrees of freedom. For a free moving, a person carries a camera around the construction site and takes multiple pictures. For the terrestrial laser scanner, it's pretty much the same, where the static means the laser scanner is placed at some selected locations, pretty much the same locations as what we did for the photogrammetry, and take multiple scans. Or we mounted this laser scanner on an autonomous robotic system, and the robotic system moves around on a path within the construction site and takes multiple laser scans. The case study that is conducted for this, that is selected for this research is in NYU-AD. And this location is specifically selected because it has a lot of clutter, a lot of pockets hidden under the surfaces and all that. Excuse me. After we collect the data, the results that we have obtained looks like this. I mean, this is kind of obvious that the photogrammetry might have more noise compared to the terrestrial laser scanners. Of course, it depends on the laser scanner that is deployed on the construction site. From the results that we have obtained, the first comparison criteria, which is economy, you see that the methodology that involves the robots and laser scanners is much more expensive compared to the rest of them in terms of initial investment. However, the photogrammetric methods that are employed have similar amount of initial investments, which is just a camera and a processing computer. In terms of operational requirements, we have two categories here, which are the data collection and data processing. In data collection, the photogrammetry has no skill requirements. It's just taking pictures. However, the terrestrial laser scanners, the person who will be monitoring, conducting this data collection needs to have skills in operating laser scanners or robotic tools. In terms of data processing, all of them requires some sort of skills, but in terms of a man hour that is required to process the data, photogrammetric method, which is free roaming, took much more time compared to the rest of them. This is just because the person was moving around with the camera and taking many more pictures compared to the static mode. And the number of pictures that are collected kind of increase the time that is required. In terms of quality, we have multiple items to compare here. The first one is the attributes. In terms of attributes, we say that the terrestrial laser scanner based methods have got the geometry data or point normal data or color and reflectance. However, the static and the free roaming photogrammetry methods, since they are just images, we can have a geometric values. We can estimate the point normals, and also we have the color values or RGB values. In terms of a point count, this is an important parameter because we kind of estimated the amount of noise that is within the data. That point count, the noise point count, is conducted by comparing the pre-filtering and post-filtering point cloud data values. Also, point cloud density is one of them. Probably one of the most interesting ones that we did here is per cell population. This per cell population is done based on voxel grid. Inside the each voxel, in each cell, we counted the number of point clouds that are available, and the less points within the cell means there is a probability of blind spot within the point cloud. The rest two, which are feasibility and value added, are qualitative criteria. So on the feasibility, we say that static methods are some sort of limitations because there are a lot of pockets hidden relative to their moving method. And also photogrammetric methods have got reduced quality because there was no uniform illumination within the construction site. In terms of value add, large projectors could take a benefit out of the robot-mounted careless systems. This is just because it reduces the waste and also it reduces the mismanagement. However, for small constructions, we cannot say this method is perfectly useful because this is case-by-case dependent, and we just propose that the contractor needs to have a cost-benefit analysis and to choose which one is the best. Concluding the comparison in here, we have plotted this, and this is mostly combining both the qualitative and quantitative criteria and comparisons that we have done so far. We say that for a small construction sites, free roaming camera photogrammetry could be useful. This is just because of its initial investment. That's the first one. And also its relative quality in terms of data. But for a very large construction site, we say robot-mounted terrestrial laser scanners could be relatively better in terms of adapting the technology because the initial investment could be relatively smaller or insignificant compared to the project amount. And also the data quality, the error, amount of error that is involved within the construction, within the data could be accumulated if there are a lot of errors, and if it has less errors, then the accumulation could be less. So this is the end of the presentation that I have for today. I will leave the floor for your questions. Thank you for your attention.
Thank you very much, Eyob. Perfect timing. So, so I haven't seen any question on the chat yet. Jose, may I ask if there's any question from the audience on site, please?
No, Professor, we don't have any questions.
Okay. Then in this case, maybe I will have one question.
Okay.
So I really appreciate that. I think it's very interesting research to compare two different types of technologies, also in terms of large scale construction sites and also small scale, large scale construction and also small scale. So I want to ask if this is also location based, because I understand that you are trying to also explore, for example, like for developing countries or for different types of, in general, the different locations, different conditions. Yeah.
Yeah, I would say it is based on conditions, because when we say developing countries, we are just considering the fact that there is a limitation in terms of infrastructure, in terms of availability of adequate tools or robotic access into the tools, and also availability of skilled manpower. There might be some locations which have all this, and there might be some other locations which have all this. Depends on the condition. If we might have a very good contractor in, let's say, less developed country, which have all the access into all these things. But I mean, it all depends on the condition that the construction, the contractor in the construction project was combined.
It's great to hear. And also, as you mentioned, that it was meant to be a poster, and now it's a short
Yes.
paper. So what is your next step?
Well, the next step is going to be exploring more into, let's say, taking a specific construction site and then comparing which one could be beneficial in terms of, instead of going into a qualitative values, but going into a quantitative estimation of which one benefited more the construction site than the other. Probably that could be a very good step forward, but this is more like the basic understanding into which one is the right direction to follow.
Okay, thank you very much. Jose, so any further question?
Do we have any question? No, Professor, we don't have questions.
Okay, thank you very much. Then thank you very much, Eyob.
Thank you very much.
And then we welcome the next